Okay, so since this is such a long review, I'm going to be doing it in two parts. So the first part's going to have the first 21, and then the second part's going to have the second 21. So this question says, write the expression in radical form. So before we write it in radical form, you need to notice that it's got that negative exponent. We don't like that. So we're going to have to fix that. So we're going to go ahead and flip it. So when we put it on the bottom, that becomes a positive exponent. Now, the way this works when we convert it into the radical is we want to take the bottom number and make that the index of the radical. Now, we don't have to put the 2 because when it's blank right here, that automatically means it's a 2. The 5 becomes the exponent on the 16, so this is 1 over 16 to the 5th power. So that's the answer to the first part. The second part says then simplify. So when we simplify, I recommend typing it into a calculator. If it gives us a decimal, then we have to show the work by hand. So I'm going to check out the square root of 16 to the 5th power. So that gives us 1024. So that means that the answer to this is going to be 1 over 1024. So we didn't really have to do any work by hand there. Okay, next question. We want to convert it to a radical since it's not a negative. So we're going to put that 27 inside the radical. And because the bottom number is in 3, that's going to be the index out here. And this top number kind of takes that slide down to the 27. So that's 27 to the 2nd power. And again, always check them in the calculator first. So to put a cube root, it's shift parentheses 27 to the 2nd power. It gives us a nice answer, so the answer is just 9. So this is the radical form, and then this is the simplified form. Okay, the next one, again, it's got the negative that we don't like, so we're going to have to flip this. So we're going to turn it into 1 over 8 to the 1/3. And that's not the answer yet. Let me rewrite that because that was ugly. 1/3. So that's not the answer yet because I haven't converted it to the radical yet. So when I convert this to the radical is going to be a cube root because the bottom number becomes the index, and then this 1 right here becomes the exponent on the 8. So this is just 8 to the 1st power. So that's over 1, or under 1, I should say. And then we've got that for the radical form. And then when we type it in the calculator, shift parentheses 8. So that gives me a 2 at the bottom. So this is going to be 1 over 2 for my final answer. And we do it in the reverse order. So we've got a negative on the inside of the radical. And since there's no exponent, we're just going to put a 1 right there. So to convert it into an exponent that's a fraction, we're going to take this 64 since it's negative, and we're going to stick it into a set of parentheses. And then the way you turn it into a fraction is this index becomes the bottom number of your fraction, and then the exponent becomes the top number. And then again, we're always going to type these in the calculator first to see what happens. So I'm going to type in parentheses, negative 64 to the 1/3 power. And oh, you know what? I forgot. The settings on this calculator are weird, and I'm not sure why it does this. So we're gonna have to turn off the complex answer. And I don't know why it does that because it's not supposed to have an I when it's a 3rd power or a 3rd root. So I'm changing it to real. So by hitting F1, and now check this out. If I go back and just re-enter the question, it actually gives me the right answer. So whoever did these Casio programmings, they need talking to because it's not right. So the answer to this is -4. So that's my rational exponent, and then that's my simplified form. Okay, the next one, you follow the same pattern. So since there's no negative and there's not multiple things in there, I'm just going to put 32. I'm going to make a fraction. The index becomes the bottom, and the exponent becomes the top. So that's going to be 32 to the 3/5. Again, check it in the calculator. So 32 gave me see, I have to hit 2 the first, 2 the, 3 on top, and then 5 at the bottom. So it gives us a final answer of 8. Rational exponent simplified. Okay, next, you notice there's a negative on the outside, and there's not a lot of stuff inside, but because there's a negative outside, we're going to have to stick that 625 inside of parentheses. So that way we can have the negative on the outside. The index becomes the bottom, and then the exponent becomes the top. So we're going to, again, type that in the calculator first. If this gave us any weird stuff, then we would have to probably break it down another way. So I'm going to put negative, parentheses, 625, close them, to the 3/4 power. So the answer is just negative 125. So that's my rational exponent, and that's my simplified form. Okay, so now we're going to have to do our stuff where we use the rules to apply all the different rules, actually. So if you notice in the first question, you've got a 4 times 4. Now, when you do 4 times 4, you don't actually do 4 times 4. What you have to do is you have to add the exponents together. So this is going to be 1/5. That's not a negative, so let me clear that off. So this is 1/5 plus negative 3/5. So if you do that in the calculator, it actually gives you, it'll give you a negative 2/5. So that means when we do this problem, we leave the 4, we add the exponents together, and that gives us a negative 2/5. Then what you're going to do is, obviously, you're going to fix that because we don't leave negative exponents. So I'm going to go ahead and write it as 1/4 to the 2/5 power. Okay, next, we're going to go ahead and distribute the exponent. So remember, everything has an exponent. So we're going to take the 3/4 and multiply it to all exponents. So that's going to give us 256 to the 3/4 power. It's going to give us x to the 3/2 power. And at the bottom, you're going to get 81 to the 3/4 power. So always check your numbers in the calculator. So you're going to get 256, 256, 256 to the 3/4 power, 3 on top, and 4 at the bottom. So that gives you 64. So on top we have 64, x to the 3/2. And then on the bottom, if I do 81 to the 3/4, I have 81 to the 3/4. That's nice because it gives 27. 64 over 27 does not reduce. So that's going to be our final answer. The next problem is pretty much done exactly the same. So this has a 1. So you're going to distribute the 1/3 to all of those. And if you don't know how to multiply fractions with regular numbers, just do that in the calculator. This is 8 to the 1/3. And then this is going to give us x to the 3rd. Then at the bottom, that's going to give us y to the 2/3. 8 to the 1/3 can go into the calculator. It's a regular number. Put 1 at the top, 3 at the bottom, gives 2. So we have 2x to the 3rd over y to the 2/3. And that's our final answer. Okay, next, when we add and subtract stuff that's in radicals, we have to make sure that the radicals are broken down. So we're going to have to make a factor tree. So 54 is 27 times 2. And then we have 9 times 3. And then this is 3 times 3. So we want to break these down based off of the index. That index means you need 3 copies. So I have 1, 2, 3. So that means that I'm going to have a 3 on the outside, and then I have this left over. So I'm going to have the cube root of 2 left over. Then the second one, I'm going to break it down. Let's see, I think that's 16 times 8. And then 16 is 4 times 4. And then we have, actually I'm going to work smart here. You know what, I'll just do it all. So 4 breaks down into 2 times 2. That 4 breaks down into 2 times 2. And this one right here also breaks down into 2 times 4, which again also breaks down into 2 times 2. So what's going to end up happening here is I got to take them out into groups of 3. So we got 1, 2, 3. So that means a 2 comes out. Then I have 1, 2, 3. So another 2 comes out, and those multiply together. Then I have this leftover. So for the second part, I'm going to have a 4 on the outside, and then the cube root of 2 on the inside. So since these guys match, since I have a 2 here and a 2 here, that means that I can actually subtract the fronts. So if I do 3, take away 4, that's -1, and then I just reattach the cube root of 2, and that's my final answer. Okay, next problem. What we can do is we can kind of separate this. So we can have the 5th root of 5, the 5th root of x to the 5th, the 5th root of y to the 6th, and then the 5th root of z to the 12th. Then you just work these pieces out individually. Now this first part, it only has one copy of the 5, so that 5 is going to stay inside. For this x, 5 goes into 5 one time. So I'm going to have an x on the outside. For the y, I'm going to have, and I need to write a big 5th root over here. I'm going to start putting my leftovers back in. So I have a 5 right here. All of these x's were used. They came out and became this x. 5 goes into 6 one time, so one x, or one of the y's comes out. 5 goes into 6 once, but then there's 1 left over, so I'm going to put a y back inside. And then my z, 5 goes into 12 2 times without going over, so this is going to be z squared. And then 5 times 2 is 10, so it's 2 short. So I put a z squared back on the inside. That's my final answer. Okay, next question. We can kind of treat this the same way. We can break it up. So 81, square root of 16, square root of y squared, and then square root of z to the 20. So remember that these are 2's. Numbers can be put in the calculator. So the square root of 81, that's just 9. This right here, I made a mistake. Let me erase this. This was x to the 16, not just 16. Okay, we're good there, nice and skinny. So we've got x to the 16. So 2 goes into 16 evenly, so that's x to the 8. 2 goes into 2 once, so that's y to the first. And 2 goes into 20 10 times, so that's z to the 10. This one has no leftovers, so that's my final answer. Okay, next question, we have to multiply. So I'm going to take this 2 and I'm going to multiply it here. So you multiply the front with the front and the inside with the inside. So this is just going to give us square root 20. Then we multiply it here. This has a 1 in front. So 1 times 2 is positive 2. And then 2 times 5 is radical 5. Oh, what am I talking about? 2 times 5 is radical 10. So let me try to erase that. So it's going to be plus 2 radical 10. And I do this next one. Now this number, it doesn't have a radical, so we have to multiply it by the number in front. So -3 times 1 is -3, and then we have our radical 10. And then -3 times that 2 is -6 with the radical 5. Now when we do these numbers, you can actually kind of work them out in the calculator. So if you want to simplify them, since they're not cube roots, you can try typing in square root of 20. So the square root of 20 is actually 2 square root 5. And the nice thing about this is we need to combine like terms. So you can see that these two guys, they're already the same. So we can put those together. So I'm going to do, let's see, 2 and minus 3 is minus 1. And then I'm going to go back over here, and I'm going to bring this down, so minus 6 radical 5. And you can see right here that we have that radical 5. It's ugly. We have this radical 5 right here and this radical 5, so we can combine their front numbers. So 2 minus 6 is minus 4 with the radical 5. And then we just bring down that minus 1 radical 10. And just like everything else, you don't need to write the 1 in front. So that's going to be my final answer. This question is pretty much the same exact thing. So we're going to take 1 times 2, so that's just 2. 1 times this is that other stuff. And then 2 times 2, since they're both outside, is going to be positive 4 with the radical 5 attached. And then 2 times this, it's going to give me a minus 2 in front. And then radical 5 times radical 5 is radical 25. So it looks like these first two can go together again. This one and this one. So I'm going to go ahead and stick those together. So I have negative 1 plus 4. Negative 1 plus 4 is negative 3. And then I'm going to bring down this plane 2. Now for this guy over here, I'm going to type that in the calculator and see what happens. So I have negative 2 radical, shift radical 25, and it gives me negative 10. So now I can put this together with this. 2 take away 10 is negative 8, and then you bring down negative 3 radical 5. That's your final answer. Okay, next question. We multiply the front with the front, so that's 12. And then when you multiply the two x's together, you just plus the exponents. So if you do 2/3, 2/3 plus 1/3, that's going to equal 3/3, which equals 1. So that means for the x's, there's just going to be x to the first power. And you don't have to put the 1 there, so that's your final answer. This one is pretty much the same, so negative 2 times 5 is negative 10. So you're going to have to do the 1/4 plus 1/2 in a calculator since they don't have common denominators. So I have 1/4. Then I'm going to go over here and hit plus 1/2. So it's 3/4. So this is going to give me x to the 3/4. That's my final answer. So now is find y using the properties of the exponents. So when we find y, we want to make sure that every single thing has a fraction as an exponent. So we're going to have to do some converting here. So for this bottom piece, the exponent is 2 and the index is 5. So that means that that's going to turn into x to the 2/5. And then we have x to the 3/5. And once, I'll go ahead and set this equal to x to the y. Once we've got these so they both have fractions, we just subtract from top to bottom. So we get x to the 1/5 is equal to x to the y. And then once you have it simplified down to a single x, you just set the exponents equal to each other. So that means for this question, x equals 1/5. Number 18, same thing. So you want to convert this into a fraction. 5 is the index, so that means that 5 has to be the denominator. 7 is the exponent, so that's the top. So this is x to the 4/5. That's equal to x to the y. Since we have the one fraction on the top and on the bottoms with the matching bases, we're going to subtract from top to bottom. So if I do 4/5 take away 7/5, that's going to give me negative 3/5. And now since I have it down to a single term on the left, I can just set the exponents equal to each other. So that means y equals to the negative 3/5. Now this question right here, it's already in fraction form, so that's good, but this one isn't. So remember, that's a 1. So that top one is going to become x to the 1/4. These ones have to times because it's a power to a power, so that's going to give me x to the 5/4 equals x to the y. and then we want to subtract from top to bottom. If I do 1/4 take away 5/4 in the calculator, it's just going to show me 1 because 1/4 take away 5/4 is 4/4. So this is just x to the 1 equals x to the y. And again, once you get it down to a single term, the tops are equal to each other. So that means that y equals 1. Okay, the last one on this section, we have to convert the top. So that's going to be a 1 for the exponent. So the exponent goes on top and the index goes at the bottom. We times these together, so that's going to be 2/3. And then we just subtract. Always subtract from top to bottom. So 1/3 take away 2/3. If you do that in the calculator, it's going to tell you it's negative 1/3. And then there's single terms, so we set these tops equal to each other. So that means that y equals negative 1/3. So not as hard as it looks. Looks fancy. Probably show your parents this and be like, yo, give me shoes, I'm smart. Okay, next one. It says circle the error. Explain the mistake that was made and then finish solving correctly. So if you look at their work, these things are already separated into stuff that are inside a radical and stuff that are not. This has an index of 2, so that means you have to use the exponent of 2 to get rid of it. And then the most common mistake, which a lot of people will not see, is this part right here. So the mistake is x squared is not equal to x squared plus 4. X minus 2 squared is not equal to x squared plus 4. So the mistake is that they did not FOIL x minus 2 squared. X minus 2 squared is not x squared plus 4 because you have to write it twice. And then you have to work it out. So I'm going to go ahead and kind of do that. So if I was to FOIL out, I'll start from the mistake right here. So if I was to do this, x minus 2 and x minus 2, that's going to give me x squared minus 2x from the first two. And then I'm going to have another minus 2x. And then it's going to give me a plus 4. So this question, it does have, and I'll do this part in bold. If you look at what they got over here, it does have the x squared and it does have the plus 4, but it did not have the minus 4x. So then we're going to go ahead and copy everything else down and finish solving. Well, when we finish solving this, we're going to go ahead and make sure it's equal to 0. So I'm going to subtract 7. Subtract 7 from here. And I'm going to add 2x to this. Add 2x here. So this question is now equal to 0. And when it's equal to 0, we all know what that means. Anytime it's equal to 0, you can just go into your solver and solve it. So we're going to go into the solver. Polynomial solver, degree 2. It's going to be a 1, a negative 2, negative 3. And it tells us that the possible answers are x equals 3 and x equals negative 1. Now we have to check. We have to check so we can decide which one is extraneous. So if I check this, checking means go back to the original problem and plug in your numbers. So if I plug this in, I'm going to have 7 take away 2 times 3. And on the right side, I'm going to have 3 take away 2. If you type this left side in the calculator, it's 1. And if you type the right side in the calculator, it's also 1, so that one works. So x equals 3 is a good answer. You try the next one. You're going to have 7 minus 2 times negative 1, all in the radical. And on the right side, you're going to have negative 1 minus 2. You type this in the calculator, all of this stuff right here is going to get you a 3. Type this in the calculator, this is going to get you a negative 3. And you can see that those are not equal because they're not the same number, so that's bad. So since these did not work, that means that this one right here is considered to be extraneous. So an extraneous answer is the right answer, it just doesn't work. And that's the first half of the review.